we will now explain how the code for breadth first traversal work. But because we have seen that the depth first traversal is actually one of the falls under one of the post order, in order, pre-order. Okay, so we can actually use one of those algorithms for that. But in case of level order or breadth first search, okay, of a binary tree, okay, we have to write our new another code. So again, this code have same four part that we have used in post order, pre-order, or in order. That is, first we declare a node. Okay, and you see the node has two uh, it has two part, the data part and the two pointer. First pointer is struct node left and second one is struct node right, where we have written in one line, because just the way you can actually declare integer x, integer y, or you can declare integer xy, same way they have declared two pointer in the same line. So I think you will not be confused with this one. Then here the first extra thing comes. This is called print given label. That means for each label, okay, each label, the program prints all the node in that label. Those of you have forgotten what is the label, let me just show you in a short. So let's assume this is a tree where all items are 4. Okay, one can be 2. Okay, so this, let's make it 14, let's make it 24. So all items are different. Okay, so this is called the label 0, this is called the label 1, this is called label 2, and if there is any other label, it will call label 3. So basically labels are, okay, we starts from root, and every time we go one step down, they are called label. So this function will actually print given label. So if you give 0, it will print 24. If you give 1, okay, it will print 14 and 4. So for each label, it will print the elements. So it takes the root node for the label and the level number. Then the height of the tree is basically for any elements. Okay, how far is it from the root? So basically I can say that this height of the tree is maximum 1, 2, 3 height. Okay, and so on. Then there's the new node function that we already used, so this is not new. So let's see what happens actually one by one. First thing that happens here is we have seen that how, just a second, that what are the functions, or what are the new functions. Print given level, this is the one new function, and integer height, that calculates the height of a node. So first thing, that the print level order, okay, this function, okay, will describe this function. What it will do, it will take a node, okay, as the input of the function. It will find the height of that node, okay, and after finding the height, okay, that is h, it will run a loop from 1 to h. So basically if the height is 2, it will calculate the height and find out with a value, that is h. And what is h, we'll just discuss this in next function, don't worry. So for any root or any node, it will first get the height, and sorry, it will first pass it to the height function. The height function will return a value. We still don't know what that value is. Okay, let's assume that value is h, and then after getting h, the program will actually run a loop that starts from 1 to h. Then we have print given level. Print given level, what it does, okay, it basically shows you that for any type of label, whether it's a left or right, okay, it actually prints the data. So it prints the, if you're in the, let me show you a diagram. So let's assume this is your tree. So it will actually print 1 and it will call function for 2 and 3. So this is called print given level. It is same as the pre-order, post-order. It's calling itself recursively. It's calling itself recursively. Okay. Then we have this height function that calculates the height of any node. Okay, what it does, it first takes the node and checks whether it's null or not. If it's null, then it's fine. If it's not, okay, the height actually calculated. The height calculated how? By calculating the height of each subtree. That means the height function call itself. And every time the function is called, okay, it returns the height plus 1. So basically, if you call the function 5 times, the height will be 5. If you can call the function 3 times, the height will be 3. Lastly, we have this new node function that we have already seen in our previous programs, and then the main function that we create tree and we print it. Now if you look closely, what happens here, we first create the tree. That's a different discussion how we create it. But here what we do, we for this tree we first pass the root. That means if the tree is like this, 1 2 4 5 6, so all you have to do is pass this one. Okay, the rest of them will be calculated automatically. So this function print level order, it will call itself. So let's just go there and see print level order. You see, print level order, this function is actually calling the height function, and it's also calling the given level function. And what is the height function? Calculates the height, which is a recursive function. And what is the given level? It's also a given function, and it's recursive. So basically both of cases, you see that the recursion is being used. So to sum things up, we are using breadth first traversal. What are the techniques? First of all, again, you have to declare a node. You have to write some functions. These two functions are new, okay, but this one I know, that's print level order, very simple. Okay, just recursively calls to calculate the height. This one, print given level. Okay, this is also same. It calculates for a given any level, it prints all the node. And finally, this is our height, which calculates the height of anyone. Okay, so after all this, okay, we have to declare the node, and finally that's it. So let me stop the recording right now.